Hey everyone, I'm Abby.
Ryan.
And we're your TAs, obviously. We are going to make a video. This is a video of innate immunity and adaptive immunity. We're going to go through the skeleton process of both. We'll go into quite a bit of detail, but we just want to give a disclaimer for what this video won't cover. So we're not going to talk about the lines of defense, like skin, earwax. You guys can dive into that. We're not going to talk about all the different types of antibodies and their role. This video will not talk about diapedesis and margination in detail. We'll kind of breeze over it. We'll talk a little bit about HLA and MHC class 1 and 2, but it can be confusing, so you might need to go back and spend some time making sure you understand the difference between those. We won't go into signs and symptoms of infection, like fever, skin flushing. You need to go back and connect it to this story.
Yeah, just go back and try to make it make sense of like what you're seeing in this cascade and how that would like manifest at like the body level when you are
Totally.
like looking at the outside of a person.
Yeah, you know we love making it make sense. Make it make sense. We're not going to go into inflammatory disorders, and we won't go into NSAIDs and drugs. So this video is a big story. We're dividing it into two. So there'll be one video on innate immunity inflammation, and then one video on adaptive immunity, which is like humoral and cell mediated. So you got it.
So what kinds of things can start off the inflammatory cascade? There's a variety of different stimuli that can cause this. So we can have things like an injury. So maybe someone got in a car accident, but like it didn't open up the skin. There's no bacteria or pathogens present, but there's been cellular injury here. There can be temperature changes, which sounds kind of silly because it doesn't really sound like an injury, and it's often not. But if I go out for a run in the morning and it's cold outside, as soon as I go outside, my nose starts running. I didn't get injured, but that temperature change is causing an inflammatory response, and that's why we see my nose running at a time like that. So temperature changes can also cause an inflammatory response. Pathogens can cause an inflammatory response. So of course, like if I get cut with a knife and it introduces some bacteria into the wound, that can cause an inflammatory response in response to the presence of those pathogens. Chemical mediators can be involved with that, as well as hypersensitivity reactions. So like here we're thinking about people who have allergies, like if someone has asthma, for example, if you're allergic to if you're deathly allergic to peanuts, like any of those things are things that can cause an inflammatory response to get caught, like to be kicked off.
All right, so kind of a forward thing that we want to say before we get going is that for every character in this story, to check your understanding, this is a list of questions you can ask yourself. You can ask, where does this character come from? Where did it come from before it got to the site? Where does it mature? Where does it live? Where is it hanging out? And then where does this character go? Where can it go? Is it gonna go to a different area of the body? Is it gonna leave the vasculature and go into the tissue? Those are the kinds of questions you're asking. And then what is its role? Every single character has a different role, and can secrete different things. It will signal different things. So you need to figure out every character and what role it plays. And then kind of the last question that will tie us from innate immunity into adaptive immunity is, does this character show up in any other part of the story? So for every character, these are the questions you're gonna ask to check your understanding, make sure you know what's going on. Okay, so we talked about how inflammation, innate immunity is going to be triggered by some sort of stimuli. And typically this stimuli is occurring in the tissue. So in the tissue, we have mast cells. Mast cells are hanging out and they're going to detect and feel whatever change just happened, whether it's a temperature change, injury, whatever. They live in the tissue. They're not mobile. They're not phagocytes. We'll talk more about phagocytes later, but they're not going around eating up pathogens or eating up bad guys. And this is what is going to trigger and start this inflammation cascade. So they're in the tissue. They're kind of sensing this damage that occurs. So if I fall and scrape my knee, we're gonna have two major responses from the mast cell. First is gonna be the immediate response. So the immediate thing that the mast cell does is release these preformed granules. We have granules that are just already in the mast cell, saving them for a rainy day, for when damage comes along. So the mast cell, it's making granules, it has granules in there, detects damage or some sort of stimulus, and it's going to degranulate. So the mast cell degranulates and is going to release these granules that have histamine in them. So immediate response of the mast cell is the release of histamine. Histamine has a few different roles. We're going to see a brief vasoconstriction. You can think of this as, let's say the stimuli that was detected was me falling and scraping my knee. To ensure that I don't completely bleed out, I'm going to vasoconstrict downstream from wherever I am, make sure that I can kind of pool my resources, brief vasoconstriction, and then the big kicker is going to be this vasodilation. We're going to vasodilate. This is going to make it so that we can get more blood and more resources to the area. And then these are kind of happening simultaneously. We're going to see vascular permeability. This makes sense why we want to become permeable is because we're about to call in a bunch of help, and that all the help is in the blood vessel. We need to become permeable so that the helpers can leave the blood vessel and get into the tissue. So this immediate response of histamine, this is what we're calling a vascular response. We're going to talk about a cellular response, but the mast cell has this initial immediate histamine response, and we're labeling that vascular response. There's also a delayed feature and role of histamine of the mast cell, where the mast cell is going to release prostaglandins, leukotrienes, cytokines, and growth factors. I think it's important to ask, what's the whole point of inflammation? The whole point is that we're going to try to contain whatever stimulus is wreaking havoc. We're going to contain it and heal it. So when we get to the end of inflammation, we're hoping that we're heading towards healing. So this is kind of laying down the building blocks of that first healing stage. It's delayed by, we have to make this on site, histamine's already made, then we make this after damage or whatever stimulus has occurred. And then this is kind of that first hint or tiptoe towards healing, which is kind of our end goal of inflammation.
Okay, so when we're talking about the cellular response, what we are talking about is the mast cells. They initially release their histamine, and then after that, they release these longer term things like prostaglandins and leukotrienes that help to perpetuate the inflammatory cascade. And one of the effects, for example, of prostaglandins or other chemotactic factors is that they are going to help to bring in the cellular response. So the mast cells are releasing some prostaglandins into the bloodstream, and then they're going to go and continue down in circulation. And so they'll create a chemical gradient going out, but the greatest amount of the chemical gradient is going to be closest to the site of injury. So for our cells that are detecting things like that, so like the first cell that arrives at the scene are the neutrophils. So this will be a neutrophil. So this is a neutrophil, and they have a sense where they're sort of like, I think of them as like bloodhounds, where they are smelling, they can smell the prostaglandins, and then they're following that chemical gradient along to the site of the injury. And then the cells are going to engage in a process called margination. So some of another one of the factors that we talked about before is cytokines. So the mast cell releases cytokines, and cytokines cause selectins and integrins to be expressed. Selectins and integrins are the part that like get expressed from the vascular endothelium and from the plasma membrane of the phagocyte itself. These are going to come and link up together, and that's going to, they'll be like an anchor and a carabiner hooking together, and so then that way the cell isn't getting like rushed away into like circulation, and so they can hook up. Then that's like the beginning of margination. Then there's diapedesis, which basically is the cell, I think of it as di like 2 and ped like feet, and then the cell is going to grow 2 feet, I think, and then he's gonna like move into the tissue. And like that's roughly like what the process is for them to get there. So let's talk about the different players or our different characters. So in the cellular response, so we have the phagocytes that are coming. So we have the neutrophils. They're the first to arrive to the scene. They're almost like EMS, I think of them like that. They are phagocytes, so they'll come and they'll eat pathogens, they'll eat like destroyed parts of cells, any cellular debris that's around there. They are pretty short-lived. They can only eat a certain amount of things, like they can eat a little bit and then they die, and then they turn into what you would see as like pus in a wound. And then there is, they're coming from the bloodstream. So although they're originally made in the bone marrow, then they move out into the bloodstream, and then like that's how they are getting to us. They do not have a role in any other parts of the process other than in our innate immunity. Next. So then we have our monocytes. So these are arriving more like 3 to 7 days later. The monocytes, when they're in the bloodstream, they're very immature. But then when they get to the tissue, then they go through like a glow up, and they mature a great deal when they enter the tissue, and then they're macrophages. They are also phagocytes, so they can come and like eat pathogens, like cellular debris and such. They're also like made in the bone marrow. They're coming from the bloodstream. And then they also have the ability to initiate healing by releasing different chemical mediators that tell the body it's time to start the healing process once everything's cleaned up and like the pathogens are gone or the threat is gone. And then they do have a role again later, because these are antigen presenting cells that will tie into our adaptive immunity. And then we have our natural killer cells. So they also are arriving later. They are also phagocytes. They're phagocytes, and then they can also kill in a way that we'll see later we'll talk about complement and killer T cells, and they have the ability to release something like a perforin, which is basically something that can drill a hole into a pathogen, and then it makes water rush in due to the concentration gradient, and then it will lyse the cell, and so then that kills directly. So they can eat things or they can kill that way. And then they're cool because they can kill virally infected cells as well as cancer cells. Lastly, there's just a quick note about a chemical mediator. There is a chemical mediator called interferon. It is released by virally infected self cells. So I think of them sort of like neighborhood watch. So if there is a self cell that gets infected with a pathogen, with a virus, then it'll release interferons to its like little community members, and then the interferons will bind to the neighborhood cells, and then it'll make it so they can't get infected by that virus.
And just note, we have some slide numbers so that you can follow along. Okay, so we talked about this chemotaxis and how it's calling in all these different phagocytes. We learned about all the different phagocytes. Now we're going to learn about some specific things they have on them that make them so effective. So on our phagocytes, which are neutrophils and macrophages, we see TLRs, which stands for toll-like receptor. And it's a receptor that's on the phagocyte that is surveying. If you think of like a toll booth, when you're going on the freeway, you have to pass through the toll booth. It's basically like these toll-like receptors, everything that passes by, they're doing a quick monitor of. So the toll-like receptors on our phagocytes are they have the ability to recognize DAMPs and PAMPs. So DAMPs and PAMPs are just labels that we're giving to patterns. So a DAMP is a damage-associated molecular pattern. So if you trip and fall, if there's a break in the skin, if there's some sort of damage or injury, then whatever pattern that presents, whether there's mediators or patterns in the plasma, whatever it is, those patterns we're labeling as DAMPs, and those patterns are recognized by these phagocytes, by the TLR specifically on the phagocyte. Pathogen-associated molecular patterns, those are patterns that the pathogens are putting out, whether it's things they're secreting, whether it's the way they move, whether it's the shape that they are. It doesn't matter. Whatever pattern they're making, we're labeling the pattern that pathogens make, we're labeling that a PAMP. So phagocytes are neutrophils and macrophages. They have TLRs, which have the ability to recognize DAMPs and PAMPs. Now, these, as you notice, it's very general. It's just a pattern. It's not specifically telling me that this is this exact virus or this exact bacteria. It might recognize a pathogen and say, oh, I think that's maybe in the gram-negative family. It is very general and there's no specifics. So that's our phagocytes, our TLRs, our DAMPs, and our PAMPs. So cytokines. We talked about cytokines briefly here, that the mast cell releases cytokines. So cytokines are messengers, they're mediators. This is basically how we're gonna continue the inflammation response. So we're gonna ask ourselves, okay, who releases cytokines? The mast cells, our macrophages do, and neutrophils. All of these characters release cytokines. The types of cytokines that we're going to talk about are TNF and IL, so tumor necrosis factor and interleukin. These are types of cytokines that are relevant to this story. So stay tuned. There's some T cell, some B cell involvement here, but we'll get to that. These cytokines, TNF and IL, what do? They are considered pyrogens. They are gonna help us mount a fever. They're gonna help call in other mediators. They are just another way to keep this inflammation story going so that we can get the end goal of inflammation and try to contain whatever damage or stimuli occurred. So B cells can use cytokines. They're pyrogens we talked about. And then there's some involvement of cytokines in this margination story when the phagocytes are trying to leave the vasculature and get to the site of injury. So summary, phagocytes have our TLRs that recognize DAMPs and PAMPs. Our phagocytes and our mast cell secrete cytokines, and we talked about what they do.
Okay, so before we previously talked about the vascular response, which was our histamine causing vasodilation and increased vascular permeability. We have our cellular response, which was refers to our phagocytes being called to the scene and coming to help eat things up. And then next, we're going to talk about sort of the third part, which is the plasma protein system response. So the plasma protein systems are made by the liver. So these are really important. So if someone was in liver failure, they would be immunocompromised because they would lose this functionality. So the liver makes these, and then they will circulate in the bloodstream in an inactive form. So with these, it would be very bad if they were activated, if they were just being active all of the time, because then you'd be getting blood clots all of the time, or you'd have complement attacking things. So we only want this to be activated when we need it. And so inflammatory mediators being released as part of the inflammatory cascade will activate the plasma protein systems and get them going. So there is the first most important and my favorite is the complement cascade. So the complement cascade they list some of the different pathways. You don't necessarily need to know those. There's just the classic pathway, which is the one that you should know about. So the classic pathway with the complement is when we have, like for example, one thing that can activate it is that we'll talk about with the adaptive immunity is that when antibodies attach to a pathogen, so here is your pathogen, and then when you have antibodies attaching to these, this is called an antibody-antigen complex. It looks kind of like a little piece of meat on a fork, but it's not. So like that's an antibody-antigen complex, and that can activate complement also. And so then complement will release something called membrane attack complex, or MAC. What MAC does is that it will essentially drill holes into the cell wall of the pathogen. That's going to cause water to rush in because now there's a concentration gradient. Water is going to rush in, and then it's going to cause the cell to burst. It's going to lyse. We saw a similar thing, like NK cells kill in a similar way. This kills in a similar way, and we'll see a similar thing again when we look at cytotoxic T cells. So this is a common theme in inflammation and immunity. And then also when complement is activated, it also helps to further perpetuate the inflammatory cascade so it keeps going. Hopefully that's a good thing in most settings. So then there's also, and then just as a side note, there's, we have the slide numbers here. So just like about the plasma protein systems in general is slide 29. Complement is 29, 30, and 31. Clotting is going to be slides 32, 33, and 34, and kinin will be 35. So our next system is clotting, which we've talked about before. This shouldn't be a new idea to you. We have like the intrinsic pathway and the extrinsic pathway, depending upon what is needed. So if there is a vascular injury and we have bleeding, then we want to achieve hemostasis because we don't want to hemorrhage or bleed out. So the clotting cascade will be activated if like when we're needing that. If there's not a vascular injury, then we're not going to see much of this. But again, this is only activated by like inflammatory mediators saying that we need to stop bleeding. This is like the one, like hemostasis is like the one place where that would be useful to have like the vasoconstriction downstream, because that would like help the clotting cascade out, because this part is happening at the same time as these, as like the vascular and cellular response. So this is happening simultaneously. And then, so lastly, we have the kinin system, and kinin is not super well understood, even like in like the literature, but so what you basically need to know is that kinin is one of the plasma protein systems. Its end product is bradykinin. Bradykinin has a role in pain signaling. Why do we want that? Pain signaling is super important because if you are getting injured, your body wants to send a message to you loud and clear to tell you that you're getting hurt, so then that way like you stop hurting yourself. So if you're burning the hand on the stove, you want to know to not be doing that, or if you like have some other like injury, that way you'll stop. There is something else though that also is involved with pain signaling. Do you remember what it is? At the very beginning we talked about prostaglandin that was released by the mast cell. So prostaglandin also is involved in pain signaling. And then bradykinin also just will increase capillary permeability and cause vasodilation, which we see in multiple places. So that way, obviously, it will continue to carry the response forward.
Okay, so that's the end of, there it is, inflammation, innate immunity. And now we're going to talk about adaptive immunity. Remember, with inflammation and innate immunity, the end goal is to try to contain it, is to try to head towards a state of healing. Anything else?
Just practice drawing this and like explaining it to somebody else. Like we are doing it here, you should draw this yourself and then explain it to other people and have them poke holes or point out what you're missing.
Totally.